Okay, Chapter 12, Section 5, we're looking at the exponential form of a complex number. Question number 41, it says, in an electric circuit, the admittance, it says, is the reciprocal of the impedance. So that means 1 over. The reciprocal of the impedance. If the impedance is, it goes on to say, if the impedance is 2800 minus 1450J, then find the value for the admittance, which is the reciprocal of this, so it's 1 divided by that, in exponential form. You know, there's two ways to go about this problem, and my first gut reaction was to multiply it by the conjugate of the denominator. So I wonder how you chose to do this, but I'm going to use the 2800 plus the 1450J, and of course I'll multiply top and bottom by that. And I've already done these calculations, so I've already FOILed this denominator. So the 2800 times the 2800 was 7,840,000, I think. I'm going to check my notes. Yep. And then, you know, I don't need to write down this outside term and this inside term because they had to be nothing. And this minus times this positive will be a minus. 1450 squared was 210,250. Remember, that's j squared because it's j times j. So essentially that's going to be plus 210,250 because j squared is equal to a negative 1 times that minus sign. So when I added these two numbers in the denominator, I wonder if I wrote them down anywhere. I'm going to grab my calculator. It's not right on my screen. So 7840. I get a total of 8,050,250. And then in the numerator, I have 2800 plus 1450J, because this 1 times this binomial just gives you that. Then what I decided to do, because I have to get this into exponential form, which means I have to find out the R value by the Pythagorean theorem, I just decided to take the 2800 and divide it by that big number. And when I did that, I got 0.0002816. And then when I took the 1450 and divided it by this 8 million, I got 0.0001458. And remember, that's j. So again, I did this by taking the numerator and putting it over the common denominator and getting these very small decimal numbers. So this 1450j divided by that 8 million. So that's how I got it. Then I turned to the Pythagorean theorem, so I took the square root of the 0.0002816 squared and the 0.0001458 squared, and I got the R value that the book got, which was 3.17 times 10 to the negative 4th power. Now, I need to know the angle, and this vector right here is in the first quadrant because those values are both positive. So I next took the inverse tangent of the y value, the 0.0001458, divided by the x value, 0.0002816, and I got about a 27-degree angle, I think. And then in exponential form, your value for theta has got to be converted into an angle in radians, so I've got to multiply that by pi over 180 degrees. And when I did that, I got 0.478, I believe. And so finally, I could write my answer now as this, I'm going to circle this in red, is this R value times e to the theta, this being my theta value, j power. So I have 3.17 times 10 to the negative 4th. 3.17 times 10 to the negative 4th e to the 0.478 j power. I need to tell you that one other possibility, if you thought about doing this way, was to take the 1 divided by the 2800 minus the 1450j and put these both into polar form. So the vector called 1 is just a vector going this way at 0 degrees. So you could write that as 1 at an angle of 0 degrees. And then this vector, by the Pythagorean theorem, the hypotenuse was 3153.17, and inverse tangent of this 1450 over 2800 was at 27.4 degrees, but because this was positive and this was negative, it's in the third quadrant. So in the third quadrant, I think that's 360 minus the 27 was 332.6 degrees. And then, you know, you could divide the r values and subtract the angles. So when you take 1 and divide it by the 3153, you get that 3.17 times 10 to the negative fourth that we already got right over here. Your angle is a negative 332.6 degrees, which its coterminal form is the positive 27-degree angle. And you can then go back and do what we did over here. Kind of a long explanation. Hopefully that helps. That was a hard problem.